Assalamu alaikum. Welcome to CSE425 Neural Networks. They are my group mates, and today I am going to give short introduction and history about RNN. My name is Ahmed Anzum, ID 19101-403. So, first of all, what is RNN? RNN means recurrent neural network. RNN are a class of neural network that are helpful in modeling of sequence data derived from feed-forward network. RNN exhibits similar behavior to how human brains function. In simple word, if I can say that recurrent neural networks produce predictive results in sequential data that other algorithms cannot. So if I come to the short history of RNN, that like many others deep learning algorithms, recurrent neural networks are relatively old. They were initially created in 1980s, but only in the recent year have we seen their true potential and increase in computational power. Along with the massive amount of data we now have to work with, the invention of the long short-term memory (LSTMs) 1990s has really brought RNNs in the fairground. The most remarkable invention in the time was, of course, by perceptrons by Frank Rosenblatt. Some people say this is the first neural network. Perceptrons was implemented in the Hughes instrument was named Mark I perceptron, and it was composed of randomly connected wires. They needed to use a big lighting fixture to get a 20 into 20 pixel image using 2020 array of cadmium sulfide photocell. However, in the research, the Rosenblatt was criticized by the Robin Minsky in a book because perceptrons could only be used for linearly separable data. Now, why need? The deep learning algorithms are commonly used for ordinary temporal problems such as language translation, neural network processing, NLP. For example, if you can say about the Apple Siri and Google Translate. So that's all from me. Thank you so much.
Assalamu alaikum. My name is Kaosar Ahmed and my ID is 19101126. So my part is types of RNN. RNN means recurrent neural networks are a type of neural network where the output from the previous step is fed as input to current step. So here are types of RNN. So from left to right, we can see one to one, one to many, many to one, many to many. So these are all of the types of RNN. Now we will see this in details. So first of all, we will see here one to one. So here we can see a rectangle is a vector and arrows represent functions. Input vectors are in red and output vectors are in blue, and green vectors hold the RNN state. So here we will see one-to-one RNN. This type of RNN neural network is known as the vanilla neural network. It's used for general machine learning problems which has a single input and output. So here in example we see image classification, and after that we'll see one-to-many. So it deals with a fixed size of information as input that gives a sequence of data as output. So this type of neural network has a single input and multiple outputs. An example of this is the image caption. Image caption takes the image as input and outputs a sentence of words. After that, we'll see many to one. This RNN takes a sequence of input and generates a single output. So it takes sequence of information as input and outputs a fixed size of the output. Sentiment analysis is a good example of this kind of neural network where a given sentence can be classified as expressing positive or negative sentiments. The example here we will see the sentiment analysis where any sentence is classified as expressing the positive or negative sentiment. So next we'll see many to many. So it takes a sequence of information as input and processes the recurrently in outputs as a sequence of data. This RNN is used to generate a sequence of output data from a sequence of input units. So machine translation is one of the example of this machine translation where the RNN reads any sentence in English and then outputs the sentence in French. Bidirectional. Next, we'll see bidirectional many-to-many. Synced sequence input and output. You notice that in every case are no pre-specified constants on the length sequence because the recurrent transformation is fixed and can be applied as many times as we like. So here is an example video classification where we wish to label every frame of the video. Assalamu alaikum. Thank you.
Assalamu alaikum. I am Tanvir Alam Nafis from section 2 ID 191015755. So I am going to talk about RNN architecture and structure. RNN is basically a unit of computation that repeats over and over. It's essentially a for loop. Here we can say we are getting input from below like xt input at every time, and we have some input which are previous state from the previous time state. This intermediate calculation emits a new output ht, and that updates the state for the next time state. For the RNN architectures, there are two main architectures that exist in almost application of RNN. Here, long short-term memory, which is called LSTM, and gated recurrent units, which is known as GRU. Both of these are used every time to calculate an output and update the internal state. The LSTM network is a type of deep RNN model composed of LSTM units. The LSTM block includes a memory cell as well as three multiplicative gating units, which are an input gate, an output gate, and a forget gate. There are recurrent connections between the cells, and each gate provides continuous operations for the cells. The cell is responsible for conveying state value over arbitrary sign intervals, and each gate performs write, read, and reset operations for the cells. A typical LSTM network is composed of different memory blocks called cells that we can see as rectangle in the screen. There are two states that are being transferred to next cell, the cell state and hidden cell. The basic GRU is similar to LSTM but only have two gates such as reset gate and update gate, and notably late and output gate, who are parameters which are generally easier or faster to train than their LSTM counterparts. Basically, GRU has no mechanism to regulate the degree, and the whole state each time is being exposed. So that's all from my side. Thank you.
Assalamu alaikum. My name is Kaosar Ahmed. I'm from section 3 and my ID is 191013228. And I will be talking about uses of RNN. So here is the main three uses of RNN. First one is sequence generation. An auto-regressive model is used to generate symbols in a sequential manner. The step is to begin with an empty symbol and then utilize the RNN to generate some outcomes. Then we take this outcome and put it into the input of the following stage. If we go ahead and do so, we will notice that our trained recurrent neural network can generate whole sequences. Next one is sequence labeling. Here it receives a sequence as input and outputs a label for each element in the sequence. In sequence labeling, we have to predict the output at each time step for every word occurring in the sequence. Pause tagging is a task of labeling the pause tag for each word in the sequence. And the third one is sequence classification. The outcome of sequence classification is determined by the entire sequence. For example, predicting the pulse of the movie by analyzing the reviews. Convolutional layers in a convolutional neural network systematically apply learned filters to input images in order to create feature map that summarize the presence of those features in the input. Next, we can see some more uses of RNN. One of the possible uses of RNN is in language modeling. Next, neural networks are one of the most powerful and extensively utilized algorithms available. The neural networks come under the subfield of artificial neural networks, and recurrent neural networks are a type of neural network that excellent at modeling sequence data, including time series or natural language. A RNN layer uses a for loop to iterate over the time steps of a sequence while maintaining an internal state that encodes information about the time steps it has seen so far. That's all from my part. Thank you. Assalamu alaikum.
Hello, Assalamu alaikum sir. My name is Uthso. My ID is 19301042. My part is the advantages and disadvantages of RNN. At the advantages of neural network is RNN can process input of any length. An RNN model is modeled to remember its information throughout the time, which is very helpful in any time series predictor. Even if the input size is larger, the model size does not increase. The weight can be shared across the time steps. RNN can use their internal memory for processing the arbitrary series of inputs, which is not the case with feed-forward neural network. Uh, and the disadvantage of neural network is due to its recurrent nature, the compulsion is slow, very much slow. Training of RNN model can be difficult. If we are using ReLU or tan-H function as activation function, it becomes very difficult to process sequences that are very long, prone to problems such as exploiting and gradient vanishing. It cannot process long sequence if using tan-H or ReLU function as activation function.
Assalamu alaikum everyone. I am Mahmudul Hasan Emon from CSE425 section 3 ID 19101098. Today I will going to present the conclusion part of our recurrent neural network model. Firstly, recurrent neural network stands at the foundation of the modern day methods of synthetic analysis. Moreover, they provide stable foundations for synthetic intelligence program to be greater, green, flexible of their accessibility, and most importantly, extra convenient to use. However, the outcomes of recurrent neural network show the actual cost of the information. They display what number of things may be extracted out of records and what this information can return. Furthermore, recurrent neural networks are better suited to analyzing temporal sequential data such as text or videos. That's why recurrent neural network is more accessible compared to other neural networks. And last but not least, recurrent neural network are powerful type of network and belong to the most promising algorithm in use because RNN is more user-friendly, and that is the reference part of our presentation. And if you have any question, feel free to ask us. Thank you, everyone.